All right, so we are looking at example 4.9 now. And it states that we have a man with some mass standing on a scale in an elevator. Okay, and we are trying to calculate what the scale will read in these two different scenarios. So the first one is if the elevator accelerates upward at some rate of 1.2 meters per second squared. Okay, so my acceleration is 1.2 meters per second squared. I have some mass, 75 kilograms. Okay, and again, we're trying to calculate the scale reading. Okay, so the first thing that they have here is a diagram of the man in the elevator on the scale. Okay, and it shows you quite a few different forces involved here. Okay, so starting up at the top, we have the tension of the elevator, of the rope that's holding the elevator. Okay, we have the weight of the person. Okay, we have the force from the scale onto the person. Okay, we have the weight of the scale, the weight of the elevator. We have, let's see, we have the force of the scale right on the floor. Okay, then we have the force of the person on the scale here. Okay, and then we have our normal force, which is the force on the floor from the, force of the floor on the scale. Okay, so all of these forces are external forces, and we are really just concerned with two main forces here, and that's what it shows here. This is our system of interest is the guy, and we want to know how much weight or what he will weigh on that scale when the elevator is moving. Okay, so we have a free body diagram, which is pretty simple here. Just our force from the scale onto him, and then we have the weight of the man. Okay, so again, we will need to construct an equation of our force. So our F net is just in the y direction, right? So I'm not going to put x or y here. And that is going to equal my positive portion. It's going to be F sub s, okay, minus my weight of the man. Okay, and since we are accelerating, as opposed to our last problem where the traffic light wasn't moving at all, the elevator is moving, okay, and it has some acceleration. So our net force will also equal that acceleration times the mass of the man. Okay, so again, we want to know how much force is being applied to this scale, basically. Okay, let me see here. Okay, so what we are looking for is this Fs, F sub s. So this is the force by the scale onto the man, okay? All right, so I'm gonna go ahead and, so again, this is for part A. I'm gonna go ahead and solve for my F sub s based on this equation here. And that is going to be m times A plus W, okay? Or m times A plus mg. Remember, gravity is in the y direction as well, okay? All right, so then all you do is plug in your values. So I have my mass of the man times my acceleration that was given in this portion, 1.20 meters per second squared, okay, plus my mass again, 75, times 9.8 meters per second squared. Okay. Then we plug that into our calculator and we get 825 newtons. Okay, again, so this is how much the man weighs on this elevator. Okay, so that's how much he is, how much weight he is applying on the scale here. Okay. Okay. So this is our first portion. Our second portion, part B, states that if the elevator is moving upward at a constant speed, so our speed is 1 meter per second, okay? And it says it's a constant speed. So that means that our speed isn't changing, right? So we don't have any change in speed. Our change in speed is 0. Okay? Meaning, come on, stay on the pin. Our acceleration then is 0. Okay, so we'll use the same equation here. F sub s equals m 75. Whoops. Whoops. Sorry about that. 75 kilograms times our acceleration, which is 0. Okay, and then add that to 75 kilograms times 9.8, because that's still, there's still some acceleration due to gravity, right? Okay, there's just not any acceleration due to the elevator. Okay, so then we get, that is 0. 75 times 9.8 leaves us with 735 newtons. Okay, so again, this is when there is an acceleration in the elevator, okay, or the elevator is accelerating. This one here is when there is no acceleration by the elevator. Okay, so no acceleration by elevator. Okay. All right, so hopefully that made some sense here. Okay. So we know our force here is the force on the scale by, or I'm sorry, force of the scale on the person, right? It's pointing up towards the guy. And that is what we were solving for. AKA, how much does this guy weigh on the scale in an elevator? Okay. All right, let's see, where is the next problem here? Okay, so this one is a pretty quick one as well. So I can go ahead and do that one with you guys real quick. So example 4.10 states that we have some soccer player that starts from rest and accelerates forward. Okay, so they start here, let's say they accelerate, whoops, they accelerate forward, okay, and reach some velocity at 8.00 meters per second at some time t equals 2.50 seconds, okay? And my first question here is, what is his average acceleration? Okay, so that's part A. Now, acceleration is, remember, it's basically a change in velocity over some change in time. Okay, and my change in velocity in this case was 0 to 8 meters per second because it said that it started from rest. Okay, so my change in velocity is 8 meters per second, and my change in time is just going to be my time, which was 2.5 seconds. Okay, So you plug that into your calculator and you get your acceleration. Okay? As 3.20 meters per second squared. Okay, so pretty simple, not too bad. Now moving on to part B. Okay, it asks what average force did he exert backward on the ground to achieve his acceleration? Okay, and it tells you that the player's mass is 70 kilograms. Okay, so I'm gonna write down his mass real quick. And I wanna know the force, okay? So remember Newton's second law states force equals mass times acceleration. So that's what we'll use here. Okay, so my force is going to be my mass times my acceleration, which we solved in part A. Okay. And then using our calculator, we end up with our force as 224 newtons. Okay. All right, so this one was pretty simple, pretty simplistic, okay, compared to those other ones, but hopefully it gives you guys just, you know, a little bit of a sense of how the questions can really range, okay? They can be pretty difficult seeming, and then we can always break them down into their components and go from there, okay? So hopefully this helped you guys a little bit, and I will be probably posting some assignments tomorrow on Friday for you guys to start doing and turn in at the end of next week. All right. All right, have a good week.